Okay, guys, this will be lesson 2 for probability. Not too difficult, but lesson 2 for probability we should continue with Venn diagrams in general. The last one was about diesel and petrol, if I'm not mistaken. Let me double check. Okay, cool. Diesel and petrol. Now, the next question would be, we'll try and do 1, 2, 3. Okay, so we'll try and do 3 Venn diagrams. And then we'll move on to probability identities. And then we should be done. Okay. The first example we do would be this one. Now, we randomly have to draw. We have to draw a Venn diagram. I'm going to start off by drawing the box because I think that's the quickest. To draw, my box is with too big. It doesn't have to be that big. Let's start. So a group of 100 students are interviewed. That's 100 people go there to find out whether they are going to study or work after they finish matric. 45 say they want to study. 45 say they're going to study, 25 say they're going to work, and 10 say they're going to do both. The rest don't know what they want to do. So if we deal with this, quite simply, we got 2 circles. For the 2 circles, I would label it as study and work. I know 45 people want to study. They gave us 10 people want to do both, and they said 25 want to go to work. Okay? Draw a Venn diagram with this information. That's fine. Now we need to always find out how many people don't want to be a part of the survey, or don't want to be a part of this thing, or don't want to study and work. They don't fall into this. So we're going to say 100 minus 45 minus 10 minus 25. So 100 minus 45 minus 10 minus 25, and that is 20 people. Now these are the people that don't want to study or work. Okay. Now what is the probability that a student chosen at random will work next year? Okay. So the probability of somebody working would be, quite simply, I want you to look at this. It does not say work only. It says work. So the entire circle for work is 25 plus 10 over 100, which is 0.35. And that's how I did the first question. Right? The next one is, what is the probability of choosing somebody? But before we go there, guys, this is the work circle. Please understand this is the circle that deals with work. So this is 35. But if it said work only, then we deal with that. Okay. What is the probability of choosing a student that will either study or work next year? So guys, when it comes to either or, it's everything. I want you to remember that it's everything. This is the or the either. So when they start talking about either or, you need to understand this is either or. It's every single person that wants to be a part of this. So the probability of work or study would be equal to 45 plus 10 plus 25 divided by 100. And this should be 25, 65, 80, 0.8. Now this one I'm okay with. I don't have a problem with this one, but when it comes to trig identities, I'm saying trig identities, probability identities, we also need to learn there's another one. So the probability of work or study has to be equal to the probability of work plus the probability of study minus the probability of work and study. So let's deal with that one. The probability of fully working I want you to pay attention. The probability of working, which we got was 0.35. So that's 0.35. Plus the probability of studying. Now the probability of studying lies there. So that is 0.55 minus the probability of working and studying, which is 0.1. Guys, this 0.1, 0.55, 0.35, these are percentages, decimals. You take the 10, divide by 100, and you get it. And if I'm not mistaken, this should be equal to 0.8. And we are correct. So that's done, and this one is the same. So the probability of somebody who doesn't know what they're doing, or none, the probability of none would be equal to 20 over 100, which is equal to 0.2. How do I know that? It's because I drew the Venn diagram. But if I wanted to use the formula, I could as well. The probability of not working or studying is equal to 1 minus 0.8, which is 0.2. Why? It's because the probability of not, I did teach you guys, the probability of not would always be 1 minus probability of the work or study. So we should be good with this question. And what is the probability of choosing somebody that's going to do both? So probability of and, work and study. Quite simple as well. We can deal with this. This is 10 over 100 or 0.1. And that's the end of this question. Okay, the next Venn diagram is 60 people were interviewed and asked whether they preferred shopping at Checkers or at Pick and Pay. 30 people said they preferred shopping at Checkers, and 55 people said that they shopped at either Checkers or Pick and Pay. 15 people said, hey, I don't shop anywhere, so it's fine. Now, what we're going to do is step 1, draw a Venn diagram. If we draw a Venn diagram, okay. That's right there. Okay, cool. My circles are not very straight, circular, but that's Checkers, that's Pick and Pay. 60 people were asked whether they like it, and what they said. 15 people said they only shopped at Pick and Pay. So 15 shopped at Pick and Pay. 30 people said they preferred shopping at Checkers. So 30 people were at Checkers. And this one is where we need to understand. 55 people said they preferred shopping at Checkers or Pick and Pay. So this circle is 55. This is Checkers or Pick and Pay. I apologize if my 5s look like S, but I can't do anything about that for now. So 55 people. Guys, this one is X. That one's easy to deal with. This one is very, very easy to deal with because if 55 people want to shop at Checkers or Pick and Pay, that means 60 minus 55 equals to 5. How do I know that? That's the total. And that's the people who want to shop at Checkers or Pick and Pay. So that's why it works out well. And then this is none. Okay? Now, if we work on it very simply, X can be solved. X is the and. How do I get the and? Remember, I didn't answer any questions. I'm just trying to get the and. It's easy. I can take 55 if I wanted to. Minus 30 minus 15. 55 minus 30 minus 15. And that would give me 10. Or I can take 60 minus 30 minus 10. Let me try and write properly. 60 minus 30 minus 10 minus 15 minus 5, and that would equal to 10. Okay, so we should be good, but we don't have this 10 here, right? So let me actually take out this 10. Apologize. Be 15 minus 5. And then now we know it's 10. So either way, you can get it, right? Now that we have all of these answers and we have this Venn diagram, it's easy. Because what can happen is draw a Venn diagram. Done. How many people shop at both Checkers and Pick and Pay? Now, guys, this did not ask for the probability. It asked for how many people. And that's 10 because that's in the center. Remember, this is the and circle. That's and. Let's go with what is the probability of interviewing someone who doesn't shop at Checkers or Pick and Pay? And we did this one as well. None. Probability of none is 5 over 60, which is 1 out of 12. What is the are these events mutually exclusive? And yes or no? Are the events mutually exclusive? Yes or no? So the answer is no. For those of you that don't understand what mutually exclusive means, we're going to get to that point, but mutually exclusive means that these events cannot happen at the same time. So I don't want you to understand, I don't want you to misunderstand. This question said they asked 60 people if they liked to shop at Checkers and Pick and Pay, not if they could shop at Checkers and Pick and Pay at the same time. So is it possible to like Checkers and Pick and Pay at the same time? Yes, it is. Therefore, it's not mutually exclusive. Mutually exclusive means it is impossible to do the two events at the same time. Most of the time, mutually exclusive would look like this. It would be two separate circles because you would never be able to do these two things at the exact same time. And that's what mutually exclusive means. So is this mutually exclusive? No. It's not mutually exclusive. And the reason it's not mutually exclusive is because people can like Checkers and Pick and Pay. Or you could say Checkers and Pick and Pay is not equal to 0. Guys, because mutually exclusive means the and must be 0. Probability of A and B must equal to 0. But since people do like Checkers and Pick and Pay, it can't be mutually exclusive. And the last one is, if 10 more people were interviewed, how many of them would you expect to fall into the Checkers group? Okay, cool. Quite simple. Guys, what I would do is get the probability of Checkers, right? The probability of Checkers is 40 out of 60. Okay? Which equals 2, I think 2/3. So that's the probability of Checkers. Now, if you get 10 more people, the probability that they would go to Checkers is 10 times 2 over 3, which should be like 6 point, my students and the 6-7 thing, 66667. Now, you can't get a 0.6%, even if they've really, really short. You have to round off people to 7. So this would be 7 people. So again, I know the probability of Checkers is 2 over 3. And if 10 people join, the probability that they would like Checkers is 10 times 2 over 3, which would give us 7 people. Because when it's people, we have to round up. Okay, guys. The next question is, people often say they are cats or dog people, or cat or dog people. 300 people were interviewed at the mall. So this value is 300. and asked if they were, which they preferred, cats or dogs, right? 282 people like cats or dogs, guys. So the Y value here is 300 minus 282. So 300 minus 282 is equal to 18. So now I know that the people that don't like cats or dogs are 18. Okay, so that one is quite simple because the or, I've been trying to train you guys to understand that this is or and this is and. So once you guys understand that, it's very easy. Determine the value of x and y. Okay, so y we ended up with 18 before we even started to answer the question. But x is a bit different. So to calculate x, we would take everything. 300 equals to 132 plus x plus 126 plus 18. 300 minus 132 minus 126 minus 118 is 24. Guys, with this one, this is basic algebra. Please understand that this x is 24. If you want to know how I did it, I just took 300 minus 132. I took everything over. Or you could even simplify if you wanted to. You could simplify and add all of this, and it should equal to that value. So now I know this is 24. That one's done. What is the probability of meeting somebody who likes both cats and dogs? The probability of dogs and cats is quite simple. So this should be 24 over 300. And this would be 0.08. All right. The probability of somebody meeting somebody that doesn't like cats and dogs, none. This should be 18 over 300. And 18 over 300, that's 18 divided by 300 is 0.06. We got the 18 from here, guys, because these are the people that don't like anything. The probability of meeting somebody who likes cats. Now, don't get confused. They did not say cats only. They said cats. So the cats is 132 plus the 24. Guys, please understand that even though this falls in the and, it is still part of the cat circle. If they said cats only, then I would focus on the 132. But they didn't say cats only. They said cats. Be 24 divided by 300. And that equals to 13 over 25, which is 0.52. Probability of somebody who likes dogs. I ran out of space. Probability of dogs. Again, it's not dogs only. Please watch out. 126 over 24. Ooh, I'm talking nonsense here. 126 plus 24 over 300. And 126 plus 24 divided by 300. And that's over 50%. Makes sense. I'm a dog person. 0.5. And what is the probability of meeting somebody who likes only cats? Now, this one is where we look at only cats. Okay? And only cats would be a 132 over 300. 132 divided by 300. And this is 0.44. Right? I do disagree with this. I can't believe that people would like more people like cats, but okay. But that's all there is to Venn diagrams. The next part is us learning about probability identities. Okay, yes. The next part of the lesson would be probability, but we're talking about the identities. Now, in grade 12, there's quite a few that you learn. But now we're going to focus on one. You see, the probability of A or B has to equal to the probability of A plus the probability of B. Oh, I'm going and. minus the probability of A and B. Now, what does that mean? It's quite simple because you and I could deal with this quite easily. We're going to pick a very random. We're going to pick a very random circle. I'm going to try my best to, let's get it as 0.3, 0.5, 0.1. Yeah, and let's put 0.1 there. Okay, so now, guys, if we look at the circle, it's not very circular, but we know this is 1, right? 1 is 100%. Let's start working on it, right? So if I wanted the AND, I just want the AND, right? We're going to talk about, let's call this A and B. If I talk about A and B, the probability is 0.1, right? We're just doing a quick recap. If I talk about the probability of A, let's go probability of A, that will be 0.3 plus 0.1, which is 0.4. If I talk about the probability of B, that would be 0.6. If I talk about the probability of none, this would be 0.1. This probability could be something called not as well. Later on, we'll learn about not. I'm trying to stay away from it until I see it in the exam papers. When I talk about the probability of A only, and A only would be 0.3. Probability of B only would be 0.5. When I talk about the probability, now pay attention, of A or B, now I'm talking about 0.3 plus 0.1 is 0.4, which is 0.9. I'm talking about everything in the circle. This is A or B. Now this is all the easy stuff, right? And most of the time, when you have the Venn diagram, it's easy to answer this. But when we don't have the Venn diagram, we can find O. So to find O, we'll take the probability of total probability of A, which is 0.4, plus the total probability of B, which is 0.6, minus the probability of both, which is 0.1. And we can see that the probability of A or B equals to 0.1. Oh, 0.9.
So
0.9.
my favorite thing, which is measurement.
So
I'm not sick.
the probability
Don't
of
have
both
any-
would be equal to 0.9.
I just simply like the taste of that.
Right, the next part of the theory lesson will be mutually exclusive. Now, we spoke about this. We spoke about it before. So it's quite simple to deal with. Mutually exclusive events. Mutually exclusive events are events where two things can't happen at the same time. Okay? Again, mutually exclusive events are where two events will never happen at the same time. It's impossible. What's impossible? Let's talk about one of my students. I don't know why they got this big head. But anyway, they were walking here and they had a choice. They could turn left or they can turn right. Now, my student would never be able to turn left and right. That's mutually exclusive. You can turn left or you can turn right. It's your choice. But you can never do both at the same time. And that's what mutually exclusive is. I don't know why the student is grumpy. I'm teaching them, so they should be happy. Yeah. But let's talk about mutually exclusive. Most of the circles that you see for mutually exclusive look like that. They never touch. They're not able to touch. And when it comes to mutually exclusive, the formula for P, A and B, PA or B is simply equal to PA plus PB. So again, we learned the other formula, PA or B is equal to PA plus PB minus P A and B. Now I'm telling you that if it's mutually exclusive, this is the formula, because now there's no center to minus, there's no and to minus, there's nothing here. So it's just straightforward, something that you have to memorize. Okay, and when we deal with this, it's quite simple. A lot of the questions we've been dealing with has mutually exclusive, but let's pick a random question. Okay, so let's go through some stuff. Let's think about whether it's mutually exclusive. Let's say there's 52 cards in a deck, and you're going to choose one card at random. Okay, and event A is the card is red, and event B is the card is a picture card. So it has a picture on it. Is the event, let's talk about this. Is the event, so event A is the card is red. And then event B let's say event B is the card has a picture on it. Okay. Is this event mutually exclusive? No, it's not, because you can pick a red card with a picture on it. Let's talk. Let's talk about another one. Somebody has a pack of cupcakes. This pack contains chocolate cupcakes, vanilla cupcakes, and red velvet cupcake. A cupcake is chosen at random from every packet. Event A is the cupcake is red velvet. Event B is the cupcake is vanilla. Now, guys, you only got 3 cupcakes. I'm sorry that my cupcakes look ugly, but I'm not good at drawing. Vanilla, red velvet, chocolate. Now, I want you to understand. Event A is the cupcake is vanilla or red velvet. Excuse me. Event B is the cupcake is vanilla. Now, you only pick one at a time at random. When you pick up one of the cupcakes, it cannot be vanilla and red velvet. It has to be one. Therefore, this time it is mutually exclusive. And the last one, one of my students named, we'll call D, plays a volleyball match, and event A is they win the game. Event B is they lose the game. Most likely they're going to lose the game. But if you had to pick one, does this mean it is mutually exclusive, or does it mean it's not mutually exclusive? So what we need to know is, even though most likely my student's going to lose this volleyball game, the truth is the probability is it's an either or. They can either win or lose, but they can never win and lose at the same time. So these two events are mutually exclusive. But note that sometimes a game could be a tie. So if it's a tie, then it's neither win or loss. But for now, it's mutually exclusive because you can't win and lose at the same time. And then let's pick another one. One of my other students' fridge has orange juice, apple juice, and grape juice. So a juice is chosen at random from the fridge. Event A is we pick the orange juice, and event B is we pick the apple juice. These are mutually exclusive because you're only picking one. You can't pick both at the same time because it said you're only picking one. So both events will not happen at the same time. Okay, guys. The last part of this lesson is called complementary. Now, there's many ways to do this. There's complicated ways and there's simple ways. So complementary means, firstly, whatever you're dealing with is mutually exclusive. And secondly, PA plus PB will always equal to 1. So what that means is, if I have 2 circles, there's A and there's B, this is 100%. There isn't anything extra. There's no people that don't like it. Let's put this as 60 and 40. This is your full 100%. There isn't anybody here in the corner that doesn't like something, or there's nothing here. I want you guys to see there's no value here where the people don't like something. Complementary means, firstly, it's mutually exclusive. Secondly, it's equal to 100%. So it's up to us to figure out and how to work with this here. But it's also very easy because we can find out a lot of things. You see the sign? The word not is shown by that sign. So whenever somebody says not B, it is quite simple. Let me show you guys what this formula looks like. PA plus PB equals to 1. So whenever anybody wants, let's go with not A. Or let's go with A in general. I'll just show you guys with A in general. If you wanted A, and if you did not want B, so I don't want B, all you have to do is take this over. And you can see PA would be equal to 1 minus PB. But let's go with the not sign. Let me show you guys what not means, because I don't want to confuse you guys. Let's take a basket. And in this basket, we have, I don't know, people that like Xbox, which is 70. People that like PlayStation, which is 30. All together, sorry guys, all together, this is 100%. This is 100. And that's all there is. Now, these people don't like both for some reason. The people we interviewed, they only like one. So if I want the people, I'm not talking about probability, I'm talking about people. The people who like PlayStation, of course, this is 30 people. If I talk about the probability of people that like PlayStation, that's 0.3. That's fine. Now, what happens if I didn't have the 70? Or what happens if the 70 was blocked to me? Right? What I could do is I could say the people who don't like PlayStation actually like the Xbox. Think about it. Because if I say the people don't like PlayStation, they automatically like the Xbox. Now, how do I get the people that don't like PlayStation? Quite simple. The people who don't like the PlayStation, it's just one that's 100% minus the people that like the PlayStation. And automatically, this is 0.7, right? But again, if you want, let me explain to you all. The P of not A is actually equal to the P of B. Because if it's not A, it has to be B. And the P of not B is equal to the P of A. So now we know that the people that don't like B are technically A, and the people that don't like A are technically B. So you can just take 1 minus the probability, or the total minus the probability. But guys, this is the end of the theory lesson. The truth is the exam papers are quite difficult, level 4, but with these 2 videos, I think we're good.